So the title of my talk today is called Change Isn't Complicated, It's Complex. Now, many of you may be thinking that I just said the same thing twice. English, if it isn't your mother tongue, these are kind of maybe nuanced words. And hopefully by the end of this talk today, you'll have a bit of separation between these two concepts. Like you mentioned, I was at Intel for a number of years. My last role at Intel was as a kind of internal change agent, a consultant, if you will, for product development teams. And we very much specialized in the curation of methods and practices to try and make the organizations better. And so I'm here today to share with some of the concepts with you. Now, this is a little bit about my own journey as a change agent. When I first started at the company, it was very much kind of a command and control approach to change, largely informed by things like the scientific management. And the company had these, $6 billion, $8 billion factories running 24/7. And so change was very, very tightly controlled. And I was going through this kind of new employee rotation program at the time. We had the opportunity to talk with the CEO of the company, which is a kind of a great honor for someone that had only been at Intel for maybe a month or so. And this is like the number 2 person in charge of the company. He's reporting directly to Andy Grove, who was our CEO at the time. And as a new hire, having an opportunity to ask this person a question was a great honor. And so one of the things I first noticed when joining the company is that, change is so tightly controlled. You have to go through all these change boards to get a change approved, lots of bureaucratic processes and procedures. And I asked him, this is, profoundly slow. Like, why do we have to do all this change management and control? Wouldn't it be better for innovation if we could just move faster and don't go through these bureaucratic processes at the time, which were called copy exactly? And the CEO at the time, he took a long pause, a deep breath, and bless his heart, he was thinking like, why am I here talking to this very junior engineer? And he looked at me straight in the face and he said, no. Next question. So there is a time and a place where change does need to be tightly controlled. It does need to be managed, and actually greatly improves innovation if you could have a standard and iterate upon that standard. So that was kind of where I started my own change journey. I had the opportunity to go back to school, got an MBA, got a systems engineering degree. I was introduced to kind of a popularized version of systems thinking, thinking about change in terms of a holistic system and approach. Under this discipline, you would use things like system dynamics. So this is a system dynamics model, if you're familiar with that. It's a model for technology adoption. You have these different stocks and flows, right? You have this one population here of potential adopters. You want to shift them to become adopters of your technology or your product or your service. And it's just a matter of creating a model and finding the levers for change. So what valves do I need to change? What buttons do I need to push to get this change to happen faster? And so we use these models, as part of our change programs. We had, different stocks of classes of people. We had the adopters, the resistors, and so it was all about trying to understand how do we model change for a large organization. Now, there's some utility in this as well. You could create these, kind of cool flight simulators, and they actually are more like a game that you play. Perhaps one of the downsides is because it is a bit of a game that there is a quote-unquote right answer, right, to these types of simulations for change. But you can develop some intuition, some ideas about how you might affect change in your organization. Now, kind of the third age that I encountered around the same time was kind of the concept of complexity and complexity theory. And that's really where this talk is going to go now. It's about taking a complexity-informed approach to change. And one person that I highly regard and look up to and that's mentored and trained me over the years, his name is David Snowden. He is the author of the Cynefin Framework. He is from Wales, so Cynefin is a Welsh word. This is his framework, and so I'll walk you through it if you are not aware of it. So Cynefin, it's not pronounced Cynefin, it's pronounced Cynefin. That's kind of the first test. It's like one of my colleagues said, it's like Kevin with a sneeze. That's a bit funny, so maybe you'll remember it that way. The simple translation is a habitat or place. It's kind of where you feel comfortable. but it's also got this more maybe nuanced definition of where you feel at home. It's a place where you belong. So for example, for me, Austin, Texas is very much my Kineton. It's where I feel at home and whatnot. And this model really is a bit of a situational awareness model. Situational leadership is kind of these management 101 type of concepts, right? As a frontline manager or as a director, you can't take a one-size-fits-all approach to management. If you're working with a junior employee or you're working with a very senior veteran that's been here 10, 15 years and knows what he or she is doing, you basically need to adjust your management style to suit the context and the situation at hand. So that's kind of situational leadership. And so Kineton, for me at least, is very much a situational leadership type of model where you need to understand the context you're in so that you can take contextually appropriate action. And if you don't understand the context you're in, very much as metaphored in this photo here, if you're not aware of kind of the nature of the circumstances that you're in, you might think you're okay when in reality you're half a hair from disaster or crisis. So this is a quote from David Snowden, and this is his photo here if you're not familiar with what he looks like. So the nature of the system determines the way we can know things, how we make decisions, and how we can act. So basically the nature of the reality that we're in, of the environment that we're in, determines how we should operate, how we should acquire new knowledge, and based on that, we can take kind of contextually appropriate action. Now, one of the easier ways I'd like to introduce Cynefin Framework is drawing it as a spectrum. So on one end of the spectrum, you have maybe decisions or environments or circumstances that are completely chaotic. And chaotic in this context are things like it's real crisis. Your house is burning down, your organization is going through some massive catastrophe. Maybe your online service is offline and it's kind of all hands on deck to try and get things back up and running. Now, the other end of the spectrum, this is where things are very obvious, very mundane. Everyone in the organization knows what the right thing to do is. It's just a matter of getting on with it and doing that right thing. Now, there's 5 domains in the Cynefin Framework. 2 more of them are kind of complex and complicated, and these are the 2 words that we'll try and tease apart throughout this talk. And then the last domain is disorder. And disorder basically means you're actually somewhere on the spectrum between chaotic and ordered. You're just not sure yet. So maybe you need to do a little bit more homework. Or disorder also looks like maybe the team is having a bit of a debate. So I think things are complicated. My teammate thinks things are complex. And we're having a differing opinion and argument, if you will, about what the right approach is. And so we just have to appreciate each other's perspective, have a dialogue, question each other on why I think it's complicated, why he or she thinks it's complex, and hopefully move forward that way. And that's one way of getting out of disordered. Now, I'd like you to imagine wrapping these 4 domains around, kind of like in a horseshoe arrangement, right? And now we're going to draw some boundaries between these domains as well, because as you transition from one domain to another, it's often very important to characterize this as a boundary transition, because when human beings cross boundaries, we change our behaviors, we adopt new ways of thinking. So boundaries are actually very important for this particular model, which is intended for social sciences. Now, this also describes why disorder is going to live kind of here in the center of the model, and why we have a fold or a cliff, if you will, between this transition from obvious to chaotic. So this transition is actually very different than the other types of transitions across these boundaries. And so we're left with this kind of weird looking, organically drawn squiggle diagram, right? With the kind of the foot at the bottom meant to be kind of a fold, like a folded piece of paper, a fold in the state space if you're a mathematician. And this is where it's kind of a step function down between obvious and chaotic. Now, as we go through this framework, we'll go through it a couple times, but we'll be talking about the nature of constraints that are at play in each of these domains and how that affects the cause and effect relationship. And we'll also talk about, based on the fact that this is the nature of reality, this is the situation that you're in, and this is how you should make decisions and act accordingly. I'll do this fairly quickly. There's lots of literature. There's an HBR article on this, so you could go and search it and do some research if you find this topic intriguing. So I'll kind of quickly go through this portion of the talk. Starting with the obvious domain, this is where you have a very direct cause and effect relationship. Things are tightly coupled together. You have very rigid constraints. This is where best practice lives, and best as in optimal. There is a singular best way of doing things. The appropriate response here is just kind of sense the situation, categorize it, and respond accordingly. So if anyone's had their internet service go off at home, you pick up the phone, you call your internet service provider, and they start walking you through some sort of script, some sort of best known way to get you back up and running. Typically, you'll hear them say things like, have you tried to unplug your modem for a minute and then plug it back in? Or you make sure the connections are correct, and things like that. And they'll start to triage and walk you through that. So this is where methods like checklists and standard processes really shine. The next domain is the complicated domain. Here we have governing constraints. It's not quite as rigid, if you will, as the obvious domain. This is where you have several good practices. There's not a singular best practice. Oftentimes when you try and impose a best practice on a bunch of perhaps engineers, when the engineers know full well that there's many good ways of addressing this problem, there isn't a singular best, you'll get some pushback from engineers when you try and impose a singular way of doing things as opposed to recognizing that there's several good alternatives. This is really where you need to sense and analyze and then respond. Analyze as in bring in the experts, rely on their knowledge, do that analysis, do those calculations, and come up with several good answers. Now, crossing over to the other side of the model, we have the complex domain. This is where we have enabling constraints. These are constraints that actually help move the system forward. The agents in the system kind of co-evolve. So the agents are influenced by the constraints of the system, and in turn, the agents can actually influence the system themselves and change it. And this is where we have this concept of emergent practice, and the appropriate response here is to probe, sense, respond. I'll talk a little bit more about probes a bit later. It's a kind of a specialized word. But essentially, you want to nudge the system, perturb it, find out what's happening, and by doing that, you could start to kind of evolve things forward. The next domain is the chaotic domain. This is where crisis lives. This is true catastrophe, if you will. Here you have little to no constraints. Not all crises are a bad thing. A lot of novelty, a lot of innovation can actually come out of crisis. I'm not sure if you've heard the phrase, never let a good crisis go to waste, right? But when your house is on fire, when your IT is down or your systems are down, it's kind of, 24/7 troubleshooting. A lot of bureaucracy, a lot of outdated processes kind of get thrown out the window during a crisis, and you could really do quite a bit of innovation. So never let a good crisis go to waste. So next time your organization is in crisis, think about investing a little bit in an innovation team to take advantage of that crisis. And here, the appropriate response is just to act, sense, respond. Don't do analysis. Don't try and figure things out. Just contain the situation, act quickly, and hopefully you could move the system forward up into the complex domain. And the last domain is in the center. Again, this is the disordered domain. This is where you're not actually sure which of the four domains you're in. Exploratory practice, explore things, discuss divergent opinions. You might need to tease things or break things apart. I think it's often safest to probe in this area as well. So do some sort of small perturbation to the system to understand your situation a little bit better. This is a bit of maybe an older framework for Kineton. So you could think of the obvious domain as the known knowns, the complicated domain as the known unknowns, and then in the complex domain, this is where you have the unknown unknowns. And actually, chaotic, you could think of this as almost unknowable. Even if you had, kind of 5 years and hundreds of engineers looking at this, there's still really no way of knowing what actually happened in a chaotic situation. Now, I think another good way to help you understand this framework a little bit better is to show you kind of a series of examples and metaphors rather than talk kind of theoretically about some of these concepts. And one of the dangers, and this is maybe a cautionary tale, but there are going to be these metaphors or these objects that I'm going to be showing you that aren't wholly in one domain or another. There are going to be some parts of it that are mostly like this situation, and there's always going to kind of be a nuanced corner case where things might be in other parts as well. So we are going to have these, problems using metaphors at some point, because on the fringe, on the edge, there's going to be some classes of things that can't be, fully categorized into a single bucket, much like this platypus. So some of the metaphors I like to use, you can think of complicated systems are things like, watches or very intricate, maybe clocks or things like that. Lots of moving parts. You could actually, take out these parts and do some maintenance on it and rebuild it and things like that. So these are complicated devices. They are predictable. There's a degree of predictability. And the other metaphor here is like a forest for complex systems. This is much more kind of an ecology, if you will, right? You have lots of moving things. It's evolving and whatnot. I think one of the funnier versions of this is from a gentleman, I think he's South African, so forgive me if I mispronounce his name, but I think it's Paul Cilliers. I'm not sure how you actually pronounce his name, but he has this funny quote, which is helpful for remembering it. But he says, "A jumbo jet is complicated, but a mayonnaise is complex." And I'll just stew on that. Why is that? Why is a jumbo jet complicated and a mayonnaise is complex? Well, a jumbo jet, you could, take it apart, tear it down to its constituent parts, do some maintenance procedure on it, stick it in a hangar over a weekend, have the technicians walk away, come back, rebuild it, and it's still a jumbo jet. At the beginning of the process, it was a jet. At the end of the process, it's a jet. You could decompose it. You could reassemble it, right? And it's a predictable, kind of ordered system. Whereas a mayonnaise has a few simple ingredients. Once you make mayonnaise, you can't unmake mayonnaise, or at least it's very difficult to unmake a mayonnaise. The mayonnaise that we make here at the morning is going to be very different than the mayonnaise you would have at the end of a long day if your mayonnaise was sitting in the sun at a picnic, right? So mayonnaise continually evolves, at least the real mayonnaise, not the fake stuff. So it's a constantly evolving system. So that's one metaphor for you. Another has to do with maybe games of chance. So you could think of a coin toss, if you will, as being obvious. Any child could know how to play a game of coin toss. Complicated is a bit more advanced, so things like blackjack, you have to memorize probability tables, you have to know the rules of the table, you have to have some expertise in card counting to get really good at blackjack. In complex, you have maybe Texas Hold'em, poker game, if you will. You go through several rounds of betting, right? You're kind of probing the system. Is this person, bluffing? What'd they do last time? What's their chip stack look this time? And so it's a much more kind of, iterative and evolving game. And then the last example here is a food fight or Calvin ball. I don't know if there's any Calvin and Hobbes fans. Calvin and Hobbes is an American cartoon about a little boy and his imaginary tiger, and they go on all kinds of adventures together. And one of the things they do on a periodic basis is play Calvin ball. And one of the rules to Calvin ball is that every time you play it, the rules change, and there's all kinds of craziness, and it's very much random and chaotic situation. Even the scoring system to know who won the game, it changes every time. So Calvin might have 12, and Hobbes might have purple, and obviously purple is winning, right? So it's kind of a fun game that they play, but it's different every time. It doesn't make any sense. Another example to help drive this metaphor home is obvious would be things like police roadblocks. Complicated, you can think of this as a traffic light at a major intersection. Again, it's really the system that's kind of imposing constraints on the agents, as opposed to a roundabout where the agents are kind of navigating their own way through the system and they're interacting with one another. And you have kind of this distributed cognition, distributed autonomy of the drivers as they navigate through a roundabout. And then lastly, we have kind of this idea of maybe Brownian motion, chaotic motion, if you will. Now, what does this have to do with change, this framework? So I'm going to now kind of cross, if you will, Cynefin with change. So obvious, this is kind of where standards, hard rules, policy enforcement would live. There is a time and a place for this type of change management in the obvious domain. In the complicated domain, you would see things like you want to define some ideal state vision, define your current state, and then it's just a matter of closing the gap between your ideal state future and your current state. And this is really where kind of things like systems thinking, popularized system thinking live. Now, as we cross into the complex domain, this is where we need to manage the evolutionary potential of the present. Because you can't predict things too far in advance in a complex system, you really need to be hyper-focused on the present, hyper-focused on the situation at hand. The Gemba, if you will, if you're a lean fan. And this is where Dave is coining the word anthro-complexity. So this is kind of a combination of anthropology and complexity theory, right? Just to create a bit of differentiation for this branch of complexity. And in the chaotic domain, you want to essentially invest in advance of need. And this is really a more recent development that I've come across. If anyone has encountered the work that companies like Netflix are pioneering in this field called chaos engineering, I think it's really fascinating. If you haven't come across it, there's some references here. But it's really this idea of using kind of randomness, random failures to kind of harden your systems, harden your infrastructure, and make it a little bit more robust and resilient. And they're doing this primarily with kind of their infrastructure, their servers and AWS and whatnot. But I also think it's interesting to think about what chaos engineering would look like inside of an organization. So if you could, unplug perhaps, key engineering talent in your organization and still have that organization be effective, so you don't have kind of these single points of failure, these knowledge hoarders. Maybe you give them a 2-month sabbatical randomly, right? And you randomly kind of unplug, if you will, employees and send them on a nice vacation just to see how your organization can react and recover. Now, we're going to do a bit of a deeper dive now into some methods, practices, approaches for managing change in complex systems. We'll go through 3 principles, 3 heuristics, and 3 methods that I found quite useful. Starting with the 3 principles, I think one important principle is that the environment and the interactions actually matter quite a bit. In fact, how the agents interact is often more important than the agents themselves. So you need to think about how agents interact, how do you change their interaction, as opposed to telling some agent that you need to change. You have to think this way. Try and change the way that people interact instead. Another important principle to keep in mind is that context is king. Because complex systems are so sensitive to initial conditions, the context of the situation is really, really important. So because things are constantly changing, it's actually quite hard to have a reproducible kind of experiment because context is so sensitive and changing all the time. And the last principle here is that complex systems are dispositional, not causal. And this is it took me a little while to kind of understand, to grok this. So I've got a short example I want to walk you through. And this is from a gentleman that Dave introduced me to his work. His name is Max Boiseau. And he has this cool little talk called The Mathematics of Dots. So you can think of 3 dots or 4 dots as kind of events, if you will. So our VP retired, for example, and that was kind of the start of one event. And as you connect things together, you kind of create these patterns of dots. So, for example, if your VP were to retire, a new VP comes in, perhaps from outside the company. That VP might be less aligned or more aligned with the changes they're trying to promote within your organization. And as a result of that, your group gets funded or defunded or whatnot. So that's kind of a series of events that would unfold. And by looking backward, you could say, okay, A caused B, B caused C, C caused D, and that's why we are where we are today. So you have this kind of retrospective coherence effect. Now, the problem with the mathematics of dots is that if you have 4 dots, you have 6 linkages. You could have up to 64 possible patterns the way that these events can unfold. If you go up to 10 dots, which is actually not that unreal for 10 things to kind of affect your organizational change that you're trying to drive, there's 45 ways that these 10 events could link up. And this is really the punchline. How many, just pause for yourself, and actually maybe turn to one of your neighbors. I'll make it a little interactive, but turn to one of your neighbors and make a guess for how many possible patterns 10 different events could link up. What do you think that number is? So tell your neighbor what you think that number is, and we'll just kind of lock it in. Obviously, it's going to be a fairly big number. How big? 35 trillion. Right? So there's 35 trillion ways that you could connect 10 dots together. So don't try and predict it. You're never going to do it. This is why systems are dispositional, not causal. They look causal looking backwards. You could see how 10 things would string together and connect. But going forward into the future, it's almost impossible to predict. So hindsight does not lead to foresight. And for the mathematicians that actually want to know the formula, there's the power law formula for you. Now, we also have 3 heuristics that we're going to talk about. So the first one is to manage the emergent possibilities of the present. Again, because of that infinite, almost semi-infinite permutation of combinations that you're facing, you really can't make too many predictions about the future. Things aren't stable. There's too many agents, too many moving parts. And really what you're left with is this heuristic of being hyper-focused on the present, trying to manage the evolutionary potential of the present, trying to kind of nudge things forward in the direction of goodness or avoid possible pitfalls. Another concept is a bit of a specialized word again called disintermediation, which basically means you need to remove the intermediaries between the frontline realities, if you will, and the decision makers. So one example I like to share in this case are things like, have you seen TV shows like Undercover Boss, right? Where the CEO of the company goes down to the front line, goes down to the Gemba, finds out how things really are. The Gemba is another one of these, lean Japanese words. It's a place where employees are working, where they create value, or the Gemba is the place where your customers are actually using your products and services. For a deep lean practitioner, it kind of has this very kind of reverent, almost deep respect for the Gemba. It's really where the rubber meets the road. So I was an engineer. One of the first weeks on the job, I noticed that my frontline manager was writing a weekly report. This was back in the day when every engineer would write a weekly report. And I noticed that he was copying the chief operating officer on his weekly reports. And this person was in charge of maybe 3,000 people in our manufacturing organization. He was kind of head of manufacturing for the company. And here this kind of engineer is sending his weekly report to this very, very senior manager. I was like, why are you, and his name was Alex. So Alex, why on earth are you sending your weekly reports to this very senior VP? And it was actually kind of a funny story. He said that he happened to bump into this VP when he came for a factory tour. And Alex had this kind of interesting kind of control point position in the fab called an integration engineer. So he was a front-end integration engineer. So it was kind of this person that had a systems view of what was happening on a day-to-day basis in the factory. And so by copying, this very senior manager, he was skipping probably 5-6 levels of management and putting this person directly in touch with what's happening on the ground in the factory. So every time that this VP would come to the factory, he would pull open Alex's weekly report, and he can ask the factory manager some interesting questions like, why is that piece of equipment not up yet? It's been down for 2 weeks. What's going on? And the factory manager would be like, how the heck did you know that, right? So that's a good way of kind of disintermediating, putting senior leaders in touch with the on-the-ground realities. The last example is to essentially grow complex systems from smaller systems that work. I think a nice quote that captures that for me, at least, is this quote from John Gall. John Gall is a pediatrician, a systems thinker, and he says that a complex system that works is invariably found to have evolved from a simpler system that worked. So what does that mean? That means that we can't actually we can't design a complex system from scratch. If we try and do that, it's going to fail. The right approach, the right heuristic, if you will, is to actually start to grow, start to cultivate, find out what's working in the here and now and the present, and amplify that, right? Grow things from where things are as opposed to trying to architect some grand change that's never actually going to materialize because it doesn't align with the evolutionary potential of the present. Now, we also have 3 methods that I've found useful. One is called simple rules. Many complex systems operate on a set of simple rules, simple principles. You may have heard of the 3 rules that birds follow to do this kind of flocking, this murmuring of swallows, if you've seen those videos on places like YouTube and whatnot. But, match the speed of your neighbor, fly to the center, and avoid collision. And by operating under these 3 rules, you'll get these kind of emergent properties of bird flocking that are really quite interesting. This approach actually works very well for informing how you might operate complex change. So one of the changes we were trying to make at the time for a group I was consulting back at Intel, we're going through kind of a lean transformation. It was about a 200, 300 person engineering organization. And the senior leader at the time noticed that a lot of engineers were kind of reinventing the wheel. There would be this kind of blocks of functionality that an engineer needed to get their job done. And rather than borrow some block of functionality, some block of code from someone that had already written this in the past, they would just, take a few hours, go ahead and code it up themselves, and use that. Now, obviously, if you have a bunch of kind of redundant, blocks of functionality, that introduces perhaps new defects, you waste a bit of time. And so the change he was trying to effect is to make things a little bit more consistent. Let's reward people for reusing knowledge, for reusing things that are proven and working. And so he came up with a simple rule, and he turned it into a mantra. And the mantra was, consistency is beautiful. And he would say it in almost every meeting, consistency is beautiful. And any time a decision needed to be made, he would say things like, we should be consistent, right? Because that's one of our values, consistency is beautiful. And sure enough, after a period of time, you start to have engineers in the hallways kind of check each other and say, I hear what you're saying, but, consistency is beautiful. Maybe we should just go with what's working today, as opposed to try and reinvent the wheel. So that's one way that you could use simple rules to kind of nudge a complex system towards a better place. And obviously, you'd have more than one, perhaps, a set of simple rules, a set of mantras or heuristics that you're trying to use for your complex change. Now, we're going to come back to this kind of idea of probes, right? Probe is a perturbation. You're kind of nudging the system. Every probe is kind of an intervention and a diagnostic at the same time. So if you perturb the system to learn something about it, you actually change the system itself. So you could think of a probe as a kind of a bet. This is one way I think of probes being a complex bet. You manage a kind of a portfolio of probes as well. So for me, at least, the scientific method, all this kind of hype over hypothesis validation or invalidation is very much kind of centered, for me at least, centered in the complicated domain. Typically, when a scientist discovers and validates some new hypothesis, they pick up the phone, they call a colleague at another lab, another university, and say, hey, I made this awesome discovery. Can you reproduce it? Can you repeat it? Right? So essentially, it's a search for reproducibility, for stability. And this is kind of in the ordered world, in the complicated domain. Now, in the complex domain, things aren't always repeatable. You could think of probes as kind of a portfolio of bets. We might launch a probe today, a pilot, if you will, and it might work very, very well for this part of the organization. And we try the same probe in another part of the organization, but because the context is different, it fails horribly. And another kind of maybe a bit disturbing, result of this type of thinking is that just because your probes, just because your interventions are working today, doesn't mean that they're going to work tomorrow, right? The system is like mayonnaise, it's constantly evolving. So whatever you're doing today that's working may actually stop working tomorrow. So things are not stable, right? Your hypothesis might be validated today and invalidated tomorrow because the system has evolved. The last method I'd like to talk a little bit about is another method that Dave Snowden introduced me to. It's his version of sensemaking. Sensemaking is a methodology, it's a practice. It's really a form of distributed ethnography based on narrative. So human beings, complex adaptive systems, complex human systems, we use a lot of narratives, we use stories. You can think of this as like water cooler conversations or the conversations you might have with an employee or a colleague over lunch. These are the rumors, right? Rumors and myths have a lot of agency in human systems as well. They can, kind of take on a life of their own, if you've heard that phrase before. So with this approach called sensemaking, you're collecting a bunch of narratives. You're having people send in stories, send in experiences, and and this is kind of where the distributed ethnography part comes in, but you're actually having the people send in the stories, add layers of meaning on top of these stories by signifying them by answering questions. So you can almost think of it as they're tagging their narrative, they're tagging their story with how they felt, with how critical was this incident, with how long are they going to remember it, or what's their story about. So you're essentially tagging your narrative with a bunch of metadata. And once you have this pool of stories tagged with metadata, you can start to do some interesting analysis, and we'll kind of walk you through a short example of that. But really what you're trying to do here is to get the organization to talk to itself about itself. It's kind of this closure of constraints type of activity where you have this reflective process where the system is reflecting on what's happening and adjusting itself accordingly. So here's one mini example. Happy to talk with you afterwards about how we've done this in different organizations. So each dot here represents an individual narrative or a story that somebody sent in. They color-coded their story based on the effect on business, a positive effect on business, a negative effect on business based on their story. The size represents how common it is. Is it rare? Is it a rare event, or is it very common? Now we're plotting this against X and Y axis on the story. On the X axis you have, this is the employees or the person sending in the story. This is their perceived perception with regards to, are they on the same page as their manager, right? So on one hand, they are on the same page as their manager. On the other hand, they're misaligned. They're not on the same page as their manager. And then on the y-axis, we have kind of their attitude towards change based on this story. Do we have kind of a keep as is attitude towards change, or are we very kind of enthusiastic and hopeful about change based on the story that you're sharing? Now, you can already see a pattern here. You tend to see more green in the upper right, more red in the lower left. And this is really kind of a key phrase that Dave uses, but he asks leaders at every level in the organization, how do we get more stories like these and fewer like those, right? So what probes, what interventions can we come up with to try and nudge the situation such that we amplify the green stories and try and get more of them? We dampen the conditions that are producing the red stories so that we could kind of constantly evolve and move this complex system that we're in to a better place. So with that, I'm going to leave you with a couple of parting thoughts. Complex change, we do need to have more of these kind of ecological metaphors for change as opposed to manufacturing ones. So think about a change agent as a gardener or a change leader as someone that's cultivating the right conditions for change as opposed to I am the architect for change, or I'm going to drive change, or I'm going to tell people what to do, I'm going to tell people how to act. You can't do that, right? These are a couple of koans. Koans are kind of, profoundly deep questions or stories or statements. They're used in Zen practice. I'm not a koan expert by any means, but I do think that it's an interesting approach for kind of reflecting on and thinking about these complex changes. So one koan you may have come across is the more things change, the more they stay the same, right? So you could ponder this, think about it a little bit. What does this mean? It seems to be a little bit contradictory. But if you reflect on this, you realize that the more change you introduce into an organization, the more people tend to fall back on the status quo. So they get numb to the monthly change process that's being deployed upon them. So I have a proposal here for everyone, a new koan, if you will, for change agents. And it's, how do you work with people, with where they are at, with what you have, to make small changes for the better? So reflect on that as a change agent. It's about going to the Gemba, staying in touch with the Gemba. It's about Kaizen, continuous small improvements. Thank you for your time.
All right. Thank you, David. Let's do a little bit of Q&A, and thanks to everybody who is using Slido and putting in some questions. So our first question is, any good practices for managing a chaotic situation?
Yeah. I think actually a lot of organizations are actually already quite good at this. Some classic things I think about are you have a crisis, your systems are going down, or you have a major excursion in the factory, and what the typical response that we would see is to try and contain the situation. You might launch kind of a 24/7 task force, get everyone that needs to be involved into the same room, into a kind of a war room, if you will. And it's really about containing the situation, stabilizing it, right? Creating some semblance of stability and order. And once you contain things, you could start to kind of nudge the system, if you will, from the chaotic domain to the complex domain. You'll have a little bit more time to run some probes to try and make sense of what's happening. So for me, at least, it's really very much kind of a firefighting affair to contain and stabilize things. So that's, I would say, you typically manage a chaotic situation.
Gotcha. Good, good. We've got another one here about the chaos part.
Yes.
And you talked about earlier about some of the, sort of probing
Sure.
in there, or unplugging pieces and stuff like this.
Yeah, unplugging, forgive me, it's such a horrible metaphor. It's very much kind of matrixy, right, where you have the batteries in the system and you're unplugging them from unplugging, probably not the best word. So forgive me for that. So this kind of the spirit, if you will, behind this concept of chaos engineering is that, yes, your systems, your AWS servers will experience kind of random failures from time to time, whether you like it or not. Much like your employees from time to time would get sick or retire unexpectedly or win the lottery, perhaps, right? So whether you like it or not, your organization will encounter the kind of these chaotic random events. And I think one of the high risk areas for your organizations is when you have kind of a senior engineer, a key person, a linchpin, if you will, of the organization that has some special bent of knowledge. They are essentially a single point of failure, right? So if they get into trouble because of some personal situation, or they win the lottery and they retire unexpectedly, that actually creates a lot of problems, because that knowledge and that way of doing things leaves the organization. So the question to you as leaders of your organization is, are you going to put up with this kind of random injection of failures that's happening anyway, or is there something that you could do kind of purposefully kind of inject failure, much like Netflix is doing, right, to harden your system, to make it more resilient, so you could have a more redundant knowledge base in your organization?
Yeah, we used to do a lot of this when I was at Google, disaster simulation stuff, and it can be very effective. So this next question goes back to the whole setup of the rubric and how to respond to it, asking whether there's not any analyze between sense and respond in complex and chaotic systems.
Right. And you'll notice that is, if you look at the three words, if you will see a gap between analysis being complicated and probe and act being in complex and chaotic. And because you're in a complex situation, because things are constantly evolving, or if you're in a chaotic situation, if your house is on fire, metaphorically, right, you don't have the luxury of time to analyze, to do some analysis. Things are moving so fast or evolving that the best you can do is kind of more tightly couple your actions, your probes, or taking action in a crisis team, and tightly couple that or shorten that time duration. Because things are constantly evolving, you want to act very quickly, and you don't really have the luxury of time for analysis. So that's one reason why analyze really lives more on the ordered side, where you have a bit more stability, where you have more predictability, where you have a little bit more time to do your homework.
I see. So if you try and analyze mayonnaise, by the time you get the analysis done,
right, or
it'll be different mayonnaise.
Heaven forbid if the theater were to catch on fire, we wouldn't do a traveling salesman problem to figure out what the best way out of here is, right?
So let's do one more with just 30 seconds or so left. And why do you prefer the constraint-based definition of domains to the causality-based definition?
Yeah, excellent question. And this is honestly, I'll be quite honest with you, this is still something I'm pondering myself. I think Dave Snowden's latest thinking is heading in the direction of constraint-based definitions. I think as human beings, when we look at the systems that we're operating in, it's actually perhaps a little bit more difficult to understand the underlying nature of the cause and effect relationship, to understand the underlying causality that's at play. And oftentimes, we could actually just observe the constraints that are going on around us. We could look at the rules, we could look at the policies. Are they hard and rigid? Are they more permeable and flexible? Is there some ambiguity in the constraints? So I think constraints, for me at least, tend to be a little bit more, I don't know, observable, if you will, or diagnosable, understandable, if you're trying to analyze your situation.
Great.
So.
Great. Thank you very much. Let's have a round of applause for David. Thank you.
Thank you.
Appreciate it.